yesterday, and then we'll keep going with those other methods of algebraically. So right up on the board here, the 4 things we got to get through. Did piecewise yesterday. I put a check mark there. Not quite sure we're ready for the check mark, but we'll see. Hopefully that's, I don't know if we earned it yet, but we'll find out. I'd say the first thing you're looking at in these is just kind of, is there one road or are there 2 roads? And that changes your approach, like what you're doing. Another time seeing it.
We did piecewise with it. So
yeah, but so then the second time you do it is kind of the third time the more you talk and you see it, the more you're gonna. I don't think I'm like some super explainer.
I just think about it.
Con can make things tougher than they have to be sometimes. Do you email Mr. Croft? Okay, so for the first one, is that 1 road or 2? That's 2 different roads. You got like one thing going on, a full equation to the left of one, and a full different equation to the right of one. And the basic question is, do they come together or not? So you're going to plug 1 into here, you'll get 7. Plug 1 into here, you'll get -4. So because you got different numbers, those roads don't meet each other. And what's the overall limit? Does not exist. So the second one was really just like one big equation there. It's just got a hole in it. But remember, when I'm looking at limits, I don't care if there's a dot there. I don't care where it is. It doesn't have to be there. So as far as the limit goes, that's all that matters to me. So all I'm doing is plugging in 4 into that equation, and the limit would be 16, because that's where the rows would be headed from both directions. This is 10, so is that bridge, the dot, or the bridge I'm calling it, in the right spot? It's not, and that means it's not continuous, but we haven't really talked about that quite yet. Those two okay? Questions? Alright. Let's do factor and cancel next. This is another kind of technique you can use. And part of the problem is you're going to get a problem in front of you. You get these like 4 different techniques, and you're not necessarily always sure which one to use. Usually can tell, but sometimes it can be a little tricky. Great, no? 15 there, not 10. So your first kind of technique or attempt is always just plug it in. Sometimes it looks like it's going to be a pain, but then you plug it in, you're like, oh, this actually works. This one won't. So if I plug in 5 into the top, I'm going to get 25. Or I'm going to get 0. If I plug 5 into the bottom, I'm going to get 0. And then you're kind of stuck. I want to show you how to do it, but I also want to show you how to write it because it matters. So if you go over here and you're like, this equals x plus 5, x minus 5, and you don't write the limit part next to it, on a multiple choice, obviously, they won't even know if you wrote the limit part or not, and nobody cares. On a free response, you have to keep running this limit part every single time. So that's part of the problem. And if you drop it, you've actually changed the problem. So don't forget to write the limit part. So I'm going to work down, so it's easier for me that way to kind of remember the limit part. So x squared minus 25 factors into x plus 5, x minus 5, right? The bottom factors into, what, well, multiplies to negative 15 and adds up to negative 2. Negative 5, positive 3. Now the x minus 5s will cancel. The limit is still in there. Like, this is still a limit question, so I'm still finding the limit as x approaches 5 of x plus 5 over x plus 3. Now I'm plugging in but again, on a multiple choice, which most of these are multiple choice, to be honest, no one cares. No one's going to see what you wrote. No one's going to care what you wrote. But a free response, you're going to have to show all that stuff. On a free response, you can leave this. On a multiple choice, this isn't wrong, but they would probably reduce, so you don't have to reduce, but you have to be able to match up with whatever they did. You know? So your answers would be like 2/3. Fourths. And for a second, you might be like, wait, my answer's not there, but if you reduce, you can get there. Good? My guess is these are going to be the easiest ones for you guys. We'll see. Try that. So again, if it's a multiple choice, I don't care what you're writing, I don't care what steps you're doing, either way. But if it's a free response, you're making sure to write that limit part every single time. That top would factor to x minus 10, x minus 2, right? Multiplies to be 20, ends up to negative 12. Bottom to x minus 10, x plus 10. Again, cancel, cancel. I still have the limit part. X minus 2 over x plus 10, and then that's just going to be 8 over 20, which you can reduce, but you don't really have. How many 8 over 20? Questions? Try this one. Trying to mess with you. See if it works. So first of all, well, I guess I don't know which one to do first. Does this bottom factor into x plus 5, x minus 5? It doesn't. It only factors if that's a subtraction. It's the difference of two squares, so it has to be a minus sign there. This won't factor. Second of all, there was no need to factor. Your first attempt should always be, can I just plug in the number? If that fails, you start moving on to other techniques. But if I plug in the number here, what's 5 minus 5? 0 over 50, that's totally fine. 0 over 50 is a number. I got $0. I'm going to split it up among 50 people. We all get $0. Like, that's just 0. So that's not like it does not exist and you have to keep going type thing. That's just 0. But that screws people up because you're so used to like doing other stuff. All right, let's try this. Just the bottom was just like I'm getting to in a second. Don't worry about this one. Just next. Before I forget what I want to go. So this one just kind of making sure you understand you can do it even if the x squared is not in front. It's just the square root of the first thing minus the square root of the second thing, and the square root of the first thing plus the square root of the second thing. I'm going to skip all the limit stuff and just kind of shorthand it. This would be 7 plus x, 7 minus x. You're just used to seeing it the other way, so I'm just kind of checking you can do it both ways. But if I FOIL this, you know, what's 7 times 7? 49. What would happen to this part of the FOIL and this part of the FOIL? They cancel, and then x times negative x is negative x squared. And then you got negative x plus 7 down here, so this is just kind of double checking too, that you realize these are actually the same thing. 7 minus x and negative x plus 7. Those will cancel. 7 plus x, and then 7 plus 7. So your answer will be 14. How many had 14? Question on it. I don't see what you did here. Where did you get this? What the hell is happening? Try the next one. This is a little tougher. We're moving the difficulty level up here a little bit. So if I factor this, I get x plus 5, x minus 5, over 5 minus x. Does anything there cancel? As it is? It doesn't. So it kind of seems like you're stuck. But there's a little trick where you can rewrite. You can do it to the top or the bottom, whichever you want. I'm going to rewrite the bottom. And would you agree that if I rewrote the bottom as negative 1 times negative 5 plus x, it's the same thing?
Yes.
I just transferred it into a way that makes my life easier. So I'm factoring out a negative 1, basically. And if I distributed that negative 1 back in, I would end up with this. So these two things are the same. I'm just kind of reorganizing to make it so I can cancel things out. And then once I do that, negative 5 plus x is the same as x minus 5. I get x plus 5 over negative 1. And then I can plug in. So the answer is negative 10. Yeah.
So I plugged in, so I made both the x's in the numerator negative.
Ooh, I like that. All right. So I think she said she noticed this wasn't going to work. So x plus 5, x minus 5, if you multiply that out, you get x squared minus 25. She's saying, okay, I just did this. Doesn't this also multiply to be x squared minus 25? Because what's negative x times negative x? Positive x squared. So you kind of like shortcutted what I did even. And then this, 5 minus x. This will cancel with this. And if you plug in 5, you'll get negative 5 minus 5, which is negative 10. Yeah, that's cool. I never thought about that. Should we do another one of those? Just to practice.
Sure.
Yes, no. Let's go along here. Try that. Very tricky one. So then I took the one that you wrote your name on. I'm sorry. You have to write your name again. I heard you're friends with Snowburger. Sad. Right? See? So I'll talk through this both ways. The way I showed and the way Morlock did. So what I was showing you is, okay, back to the bottom like we're used to. And then nothing cancels here, so I'm reorganizing the top, pull a negative 1 out so that these two things will cancel, and then plug in. Another way to do it would be, okay, instead of doing x plus 8 and x minus 8, let's do negative x plus 8 and negative x minus 8. And then the negative x plus 8 will cancel. And either way, when you get to the end and plug in, you will get negative 1 over 16. How many had negative 1 over 16? Awesome. Question on that? Try that top one there. This is pretty tough. Okay. Maybe I'll let you know what to do. So if you plug in, you get 0 over 0, right? The next thing is, okay, what can I do so that I could fix that? Is there a way I could factor it to take care of that issue? All right, let me go through it. At some point, time's not gonna help you. How many things I got? Anybody? All right. Let's see. So the general factoring rule is if you have a squared minus b squared, that'll factor into a plus ba minus b, right? Because the a times a will give you the a squared, the b times the negative b will give you the negative b squared, and then these two other parts just go away. You're used to only doing that if you realize, oh, that's something squared. I'm gonna if it's a 16, okay, I'm gonna square root and get 4. If it's 49, I'm gonna square root and get 7. There's nothing that says you can't do it with this. There's just usually not a reason to. But couldn't I take this? Like if I think of this x as the a squared, what would the a be? Does that make any sense? Like if this a squared minus b squared is x minus 8, then what goes down here? Square root of x plus 8, square root of x minus 8, right? So you can do the difference of two squares, even though these things don't easily square root, because you're used to x squared minus 9. Oh, okay, x and 3, plus and minus. But there's no reason you can't do it with x and 8. Square root of x, square root of 8, plus and minus. So this can become square root of x plus 8, or plus square root of 8, square root of x minus square root of 8. You can use the same rule, it's just you're not used to applying it in that situation. Then those will go away. You're left with the square root of x, so now I have the limit as x approaches 8 of the square root of x plus the square root of 8. Now if I plug 8 in place of x, will I get 0 over 0? No. I will get the square root of 8 plus the square root of 8, which you are allowed to just leave as it is. Wanted to combine it, that's just 2 times the square root of 8. Question on that one? Naomi?
I did it where I didn't get the same answer, but I'm wondering if it was still worth it if I did a mistake wrong.
Okay.
I did it where I squared both top and bottom to get rid of the square root sign.
It doesn't work.
Okay.
So I'll show you why. So if you have like 2/3 and you multiply the top by 4 and the bottom by 4, then you get 8/12. Are those two really the same value? 2/3 and 8/12? Yeah, they are. They mean the same thing, right? So because I didn't really change it when I multiplied by 4. So you're thinking like, oh, if I do the same thing to the top and the same thing to the bottom, it should work out. But when you square, now I have 4 9s. I'm just taking a random number. Does 4 9ths reduce to 2/3? Like, are those really the same fraction? This is the part where you say yes. Or I'm going to take a different number. Take like 5 over 10. Let's square it. You get 25 over 100. Does 25 over 100 have the same value as 5 over 10? So this is how I got through math in high school, I would say. Like, I don't remember these rules. I mean, I do now because I've been teaching for 20 years, but I would have had the exact same question sitting in calculus in high school. What if I just squared them both? And so then what I would do is like test it. And this is like a strategy I would strongly encourage you to use. Like, I mean, sometimes I get to the point, I mean, not anymore, but I'd get to this and I'd be like, crap, I can't remember if that's x to the 11th or x to the 28th. Like, am I supposed to add those two things or am I supposed to multiply them together? Just test it. Make up your own numbers. Like, take 2 to the 3rd times 2 squared. And then see if that equals 2 to the 5th or 2 to the 6th. And if it equals 2 to the 5th, well, then you're supposed to add those and then go back and make that 11. If it equals 2 to the 6th, well, then I better multiply them and then go, you know what I mean? So I forgot rules constantly. And I expect a lot of you will ttoo, but you can kind of figure them out. Does that make sense, Naomi?
Yeah.
Does that help? Okay.
One more.
Yeah.
I did it, but instead of doing the difference of squares with the numerator, I saw the root x minus root 8 as half difference of squares and multiplied by the reciprocal. So the root x plus root
That's
8.
the next strategy we're going to use.
That's the rationalization.
That's rationalizing.
Okay.
Yeah. So that's another way to do it, so we'll bring that up in, I don't know if we can do it today, but soon.
Okay.
If not today, then Monday. That's cool. Did you get the right answer?
Yeah.
Cool.
Kind of cutting me still rattling around.
Nice.
So.
Nice. Other questions on that topic? So what he's saying is he rationalized it, which we'll get to. That's another approach. Don't have to do it that way, but you could. So this is similar. Try that bottom one there. And you did it last year too, right? So that's pre-calc and then Khan Academy, and then when I do it, so that third time, hopefully, we'll make it stick for people. Hopefully. Mic drop over here. So there's kind of two approaches. Like Quinn was saying, you can do it the other way. My idea here is, so your two ideas are, could I take this and get rid of the square root so that it matches up with this? Or could I take this and give it a square root so it matches up with the top? And I'm teaching the factoring way, so we're going to give this bottom a square root. So the top is the square root of x minus 4. Could I use difference of squares to factor this x minus 16? I could, and I can make that the square root of x plus the square root of 16, or the square root of x minus the square root of 16. The square root of x minus 16 is the same as the square root of x minus 4, right? So we get 1 over the square root of x plus the square root of 16. So 1 over the square root of 16 plus the square root of 16. I guess at some point I could say that the square root of 16 is 4. The answer is 1/8. I mean, 1 over 8. Questions? Question, or you're just raising your hand?
No,
10 seconds after everybody else.
yeah.
Okay. Try this one in the middle. I don't think that's really anything tricky, but just that negative sign out there, I want to make sure you see it. Know what to do with it at the end. I'm more worried that you won't see it than you want to do with it. Just kind of pointing out, like, hey, sometimes they throw a negative in front, so be on the lookout for that. It's interesting. Except for Quinn and Caitlin. All the guys went to the back of the room. All the girls were in front. No one else thinks that's interesting, I guess. No. So x squared minus 9 becomes x plus 3x minus 3. And again, I'm doing this like it was multiple choice. I'm not worrying about like rewriting. The bottom becomes x plus 7x minus 3. I should stop before I do this though. Why am I even bothering to factor? What didn't work? Plugging in won't work because you get 0 over 0. But you should try that first. Then these will cancel. 3 plus 3 is 6. 3 plus 7 is 10. And just make sure you put the negative sign in front. Like, I don't think that's hard. I just want to make sure you realize they might put a negative sign in front. Question on any of the factoring stuff? Yeah.
This one, you just about factoring in general. Is it possible to factor everything down and still end up with 0 over 0? Or would that not realistically happen?
Yeah, I'm going to say that wouldn't realistically happen. I'm tossing around like hypotheticals in my head. Like, it's not going to happen at your test. But I'm like, okay, wait, what about like I'm interested in answering the question? So I'm not going to like think about it too much right now. Or that's fair.
Alright, that's fine.
Okay. If everything cancels, I could just yeah. I'm going to think about it, but
Like if it's x over 0, you're left with x over x.
like if everything cancels, just be 1.
Yeah.
Oh, there is one more kind of factoring question I want to show you. Try this one. That reminded me of this. Thank you. So this is like a slightly different kind of factor. Still factor. So always try to plug in. But if you plug in, you get 0 over 0, right? So it's like, okay, now what do I do? Now what do I do? So there's kind of two ways people think about this. One way would be to look at the top and bottom separately. I'm going to factor what I can from each. So couldn't I take a 2x squared out of the top, which would leave me with 2x plus 3 on the inside. You guys see what I'm doing there to get that? So if you distribute it, you'd end up with what you had up here. At the bottom, I could take out an x squared, which would leave me with 5x plus 3. Then could I plug in 0? Still not quite yet, but what if I did this? Now can I plug in 0? So that's one way you could do it. And the other way, which I think is simpler, is you could just look at this and be like, okay, every single term in there has at least an x squared in it. And just start chopping up x squared, because all 4 of them have it. Just chop an x squared out of everything. So then this would be 4x plus 6 over 5x plus 3. Which isn't that exactly the same thing we have over here, just written a little differently. Because this is just 4x plus 6 also, right? Then if you plug in 0, you get 6 over 3. So your answer would just be 2. How's that? Do one more. I don't even know how to make this really like all that different. But there you go. I think the way where you see, like, okay, they all have at least this many x's in it and cancel all of them out at once, I think that's a lot easier. Less steps. It's more like intuitive, I think, for most people. So I would just look at this and go, okay, there's at least an x to the third in all of those. So I'm just chopping off. Those x to the thirds are gone. Those x to the thirds are gone. There's only one left there. There's only one left there. Now I just have 3x minus 6 over 4x plus 5. And now if I plug in 0, I'll just get a negative 6 over 5. Oh, yeah. Cool. Questions? Okay, so get this out. The same packet that I gave you before. And we have not gone through how to do number 7, number 9, or number 12. But I believe, I'm just double checking, everything else on there, and that's the rationalizing. That's what we haven't gotten to yet. One of the things we haven't gotten to yet. So you should be able to do every problem on this worksheet now except for 7, 9, and 12. And that's what we'll start with next time, is the rationalizing. So you have a ton of time to get sometimes start those. Let me know if I can help. Whatever you don't finish up for Monday.